There are a number of different ways you can solve the problems that we've been doing that have information and ask for an expression. I'm going to show you one way that we'll use the way that we've been solving some of the tables when we've been completing the rules on a table. For example, let me just squeeze this up in here before we read this problem. We've been doing problems like this where you have, say, W is the variable, and I tell you that I've got 3 and 18 is the answer that we get when we apply the rule to 3. And I even tell you that the rule starts 3x, and then I asked you to complete the rule. Well, you were doing 3 times 3 is equal to 9, and then something, what you do with 9 to get to 18, you add 9 to it. So that would suggest that the rule is 3x plus 9, and then you would check that with some of the other entries on the table. So we're going to use that method to solve this problem. Sarah went to the bank to open a bank account. She deposited the money she had saved from birthdays and holidays. Each week she put the $12 she earned from babysitting into the account. After 7 weeks she had $250 in the account. It says how much did she deposit at the beginning, and it also asks us to write an expression. I'm going to start here thinking about the expression. In the problem, I notice it says each week she put $12 into the account. So each week tells us that we've got a rate. The amount of that is $12. So I know that I'm going to start my rule doing 12 times W, 12 times the number of weeks. And now what I need to do is I need to finish that rule, just like what we were doing with the tables. It doesn't look like I have a table, but in fact I do. I have 2 pieces of information. One is a number of weeks, and another is the number of dollars that are in the account. So that table would look like this. W is the number of weeks. In this case it's 7. And if I put 7 into my rule, I get 250 out as the answer. All right, so let's start. 12 times W, 12 times 7 in this case. 12 times 7 equals 84. That means that it's going to be 84 plus, could be a negative number, something, equals 250. Well, in this case, it's clearly going to be positive. So I'm going to go ahead and subtract 250 minus 84. And I know, just to save time, I know that that answer is 166. All right. So looking at it kind of from an algebraic standpoint, I took 84 from that side, took 84 from this side, and I found that B equals 166. So that means that the rest of my rule has to be plus 166, because I did 7 times 12. That got me 84. What do I have to do to get the answer of 250? I have to add 166. That's the rule. How much did she deposit at the beginning? Well, that must be the amount that she deposited at the beginning. That's that extra amount. So I've also answered this question. Let's take a look at another example. Rick is making holiday cards to send to friends. His mom asked if she could have a few. He makes 9 cards per hour. After 14 hours of work, he had 109 cards for his friends. How many cards did he give to his mom? And write an expression for the number of cards he has for his friends after 8 hours. Well, again, I'm going to start thinking down here. Let's start with the expression. Well, reading through the problem carefully, I see here is the rate, 9 cards per hour. So that's going to be 9 times the number of hours. Then I'm going to need to complete the rule in order to get my expression. Where's my data? It's up here. 14 hours of work and 109 cards for friends. Hours, that's my variable. That's what I'm using here. 14 hours. I put 14 hours into the rule. The rule starts, I know that the rule starts at 9 times 14. So 9 times 4 is 36. 9 times 10 is 90. 90 plus 36 is equal to 126. So it looks like 126 plus or minus could be a negative number. Something gives me 109. Well, it looks like this is going to be a subtraction. So I'll do 126 minus 109. And that gives me 7. And I'd like to set it up like this, actually. And that's going to give me 17, isn't it? 16 minus it with 1. So it's 17 cards. And I had to take 17 cards away. So it's 126 minus 17 equals 109. So that's a negative b. My rule is take away 17. Multiply by 9 and then take away 17. How many cards did he give to his mom? Well, it must be the 17 cards that he gave away. So that's the answer there. Let's do a couple more. Adam completed 3 problems on the math worksheet every minute. After 10 minutes, there were 8. So it's 3 problems for every minute. But there's something important in this problem that I have to notice, and that is that every time he does 3 problems, the number of problems left gets less. So in this case, it's a negative 3 because it's going down for every minute. Negative 3m, and then something for my rule. Let's complete the rule. Where's my data? Well, m is my variable, so minutes, and we have after 10 minutes, there were 18 problems left. So I'm going to use my negative 3m and then finish the rule. So negative 3 times 10 is equal to negative 30. Plus or minus something is going to give me 18. Now you might notice, you might be able to figure that out, that if it's negative 30 plus that, this has got to be a bigger number. But this would be a great place to use algebra, I think. So negative 30 plus b is equal to 18. I'm going to add 30 to both sides. And I'm going to get b equals 48. Now I'll just double check that a second here. If he did 30 problems, negative 30 problems are gone, plus the 48 and negative 30, yep, that equals 18. So negative 3m plus 48. How many problems were on the math sheet to begin with? This must be the original, and then I'm subtracting this part away. So I've got 48 problems that are on the math worksheet to begin with. Another way that you could write this, that we've sometimes written it in class, is 48 minus 3m. So the negative on the other side there. Let's take a look at one more. And remember, you can always pause these anytime and rewind if something's a little bit, if you want to look at it again. Mia loves candy corn. She still has some left from Halloween. She ate 12 candy corn kernels per day. After 7 days, there were 146 kernels left. How many candy corn kernels did she start with? And write an expression for the number of kernels left after d days. Again, we'll start down here and we'll think about it. What's the expression going to start with? Well, I noticed that it's 12 candy corn kernels per day. So it's going to be 12 times d. But I also noticed that the number of corn kernels left is going to be going down. So each day, that's a negative 12. It's taking away from the amount that I started with. So I'm going to want to complete that. Here's my table. My variable is D. That stands for days. So 7 days, that's my data, 7 and 146. Well, I start with my rule, that's negative 12 D and something. I'm going to go negative 12 times 7. That equals negative 84. Now my rule is negative 84 plus or minus something is equal to 146. So again, if I put a variable in that spot, negative 84 plus b equals 146. To solve for b, I got to get rid of this. I'm going to add 84 to both sides. B, sorry, it looks like a 6. B is equal to 10, carry the 1, 5, 3, 230. It's a positive number plus 230. How many candy corn kernels did she start with? That's the amount. And then we're taking this away from it as the number of days increases. So how many did she start with? She started with 230. Hopefully that's helpful.